principles which lead in direct philosophical inquiries illustrated by the history of the ancient physics. From arranging and methodizing the system of the heavens, philosophy descended to the consideration of the inferior parts of nature, of the earth, and of the bodies which immediately surround it. If the objects which were here presented to its view were inferior in greatness or beauty, and therefore less apt to attract the attention of the mind, they were more apt, when they came to be attended to embarrass and perplex it, by the variety of their species, and by the intricacy and seeming irregularity of the laws or orders of their succession. The species of objects in the heavens are few in number. The sun, the moon, the planets, and the fixed stars are all which those philosophers could distinguish. All the changes, too, which are ever observed in these bodies, evidently arise from some difference in the velocity and direction of their several motions. But the variety of meteors in the air, or of clouds, rainbows, thunder, lightning, winds, rain, hail, snow, is vastly greater. And the order of their succession seems to be still more irregular and unconstant. The species of fossils, minerals, plants, animals, which are found in the waters and near the surface of the earth, are still more intricately diversified. And if we regard the different manners of their production, their mutual influence in altering, destroying, supporting one another, the orders of their succession seem to admit of an almost infinite variety. If the imagination, therefore, when it considered the appearances in the heavens, was often perplexed and driven out of its natural career, it would be much more exposed to the same embarrassment when it directed its attention to the objects which the earth presented to it, and when it endeavored to trace their progress and successive revolutions. To introduce order and coherence into the mind's conception of this seeming chaos of dissimilar and disjointed appearances, it was necessary to deduce all their qualities, operations, and laws of succession from those of some particular things with which it was perfectly acquainted and familiar, and along which its imagination could glide smoothly and easily, and without interruption. But as we would in vain attempt to deduce the heat of a stove from that of an open chimney, unless we could show that the same fire which was exposed in the one lay concealed in the other, so it was impossible to deduce the qualities and laws of succession observed in the more uncommon appearances of nature from those of such as were more familiar, if those customary objects were not supposed, however disguised in their appearance, to enter into the composition of those rarer and more singular phenomena. To render, therefore, this lower part of the great theatre of nature a coherent spectacle to the imagination, it became necessary to suppose, first, that all the strange objects of which it consisted were made up out of a few with which the mind was extremely familiar, and secondly, that all their qualities, operations, and rules of succession were no more than different diversifications of those to which it had long been accustomed in these primary and elementary objects. Of all the bodies of which these inferior parts of the universe seem to be composed, those with which we are most familiar are the earth, which we tread upon, the water, which we every day use, the air, which we constantly breathe, and the fire, whose benign influence is not only required for preparing the common necessaries of life, but for the continual support of that vital principle which actuates both plants and animals. These, therefore, were by Empedocles and the other philosophers of the Italian school supposed to be the elements out of which, at least, all the inferior parts of nature were composed. The familiarity of those bodies to the mind naturally disposed it to look for some resemblance to them in whatever else was presented to its consideration. The discovery of some such resemblance united the new object to an assortment of things with which the imagination was perfectly acquainted. And if any analogy could be observed betwixt the operations and laws of succession of the compound and those of the simple objects, the movement of the fancy, in tracing their progress, became quite smooth and natural and easy. This natural anticipation, too, was still more confirmed by such a slight and inaccurate analysis of things as could be expected in the infancy of science, when the curiosity of mankind, grasping at an account of all things before it had got full satisfaction with regard to any one, hurried on to build, in imagination, this immense fabric of the universe. The heat observed in both plants and animals seemed to demonstrate that fire made a part of their composition. Air was not less necessary for the subsistence of both, and seemed, too, to enter into the fabric of animals by respiration, and into that of plants by some other means. The juices which circulated through them showed how much of their texture was owing to water, and their resolution into earth by putrefaction discovered that this element had not been left out in their original formation. A similar analysis seemed to shew the same principles in most other compound bodies. The vast extent of those bodies seemed to render them, upon another account, proper to be the great stores out of which nature compounded all the other species of things. Earth and water divide almost the whole of the terrestrial globe between them. The thin transparent covering of the air surrounds it to an immense height upon all sides. Fire, with its attendant, light, seems to descend from the celestial regions, and might, therefore, either be supposed to be diffused through the whole of those ethereal spaces, as well as to be condensed and conglobated in those luminous bodies, which sparkle across them, as by the Stoics, or to be placed immediately under the sphere of the moon, in the region next below them, as by the Peripatetics, who could not reconcile the devouring nature of fire with the supposed unchangeable essence of their solid and crystalline spheres. The qualities, too, by which we are chiefly accustomed to characterize and distinguish natural bodies, are all of them found, in the highest degree, in those four elements. The great divisions of the objects near the surface of the earth are those into hot and cold, moist and dry, light and heavy. These are the most remarkable properties of bodies, and it is upon them that many of their other most sensible qualities and powers seem to depend. Of these, heat and cold were naturally enough regarded by those first inquirers into nature as the active, moisture and dryness as the passive qualities of matter. It was the temperature of heat and cold which seemed to occasion the growth and dissolution of plants and animals, as appeared evident from the effects of the change of the seasons upon both. A proper degree of moisture and dryness was not less necessary for these purposes, as was evident from the different effects and productions of wet and dry seasons in soils. It was the heat and cold, however, which actuated and determined those two otherwise inert qualities of things to a state either of rest or motion. Gravity and levity were regarded as the two principles of motion, which directed all sublunary things to their proper place. And all those six qualities, taken together, were, upon such an inattentive view of nature, as must be expected in the beginnings of philosophy, readily enough apprehended to be capable of connecting together the most remarkable revolutions which occur in these inferior parts of the universe. Heat and dryness were the qualities which characterized the element of fire, heat and moisture that of air, moisture and cold that of water, cold and dryness that of earth. The natural motion of two of these elements, earth and water, was downwards, upon account of their gravity. This tendency, however, was stronger in the one than in the other, upon account of the superior gravity of earth. The natural motion of the two other elements, fire and air, was upwards, upon account of their levity, and this tendency, too, was stronger in the one than in the other, upon account of the superior levity of fire. Let us not despise those ancient philosophers for thus supposing that these two elements had a positive levity or a real tendency upwards. Let us remember that this notion has an appearance of being confirmed by the most obvious observations. Then those facts and experiments which demonstrate the weight of the air, and which no superior sagacity but chance alone. Smith gives no indication of what he means by chance in this context. The experiments on the weight of the air were amongst the first and best documented of the new experimental philosophy. Presented to the moderns, were altogether unknown to them. Ah oui, aussi, oui, Anaxagoras showed experimentally that air was corporeal, but it seems to be true that no ancient thinker proved that it had weight, and that what might, in some measure, have supplied the place of those experiments, the reasonings concerning the causes of the ascent of bodies, in fluids specifically heavier than themselves, seem to have been unknown in the ancient world, till Archimedes discovered them in his treatise on floating bodies. Long after their system of physics was completed and had acquired an established reputation, that those reasonings are far from being obvious, and that by their inventor, they seem to have been thought applicable only to the ascent of solids in water, and not even to that of solids in air, much less to that of one fluid in another. But it is this last only which could explain the ascent of flame, vapours, and fiery exhalations, without the supposition of a specific levity. Thus each of those four elements had, in the system of the universe, a place which was peculiarly allotted to it, and to which it naturally tended. Earth and water rolled down to the centre. The air spread itself above them, while the fire soared aloft, either to the celestial region or to that which was immediately below it. When each of those simple bodies had thus obtained its proper sphere, there was nothing in the nature of any one of them to make it pass into the place of the other, to make the fire descend into the air into the water, or the water into the earth; or, on the contrary, to bring up the earth into the place of the water into that of the air, or the air into that of the fire. All sublunary things, therefore, if left to themselves, would have remained in an eternal repose. The revolution of the heavens, those of the sun, moon, and five planets, by producing the vicissitudes of day and night and of the seasons, prevented this torpor and inactivity from reigning through the inferior parts of nature, inflamed by the rapidity of their circumvolutions the element of fire, and forced it violently downwards into the air, into the water, and into the earth, and thereby produced those mixtures of the different elements which kept up the motion and circulation of the lower parts of nature; occasioned, sometimes, the entire transmutation of one element into another, and sometimes the production of forms and species different from them all, and in which, though the qualities of them all might be found, they were so altered and attempered by the mixture, as scarce to be distinguishable. Thus, if a small quantity of fire was mixed with a great quantity of air, the moisture and moderate warmth of the one entirely surmounted and changed into their own essence the intense heat and dryness of the other, and the whole aggregate became air. The contrary of which happened, if a small quantity of air was mixed with a great quantity of fire, the whole, in this case, became fire. In the same manner, if a small quantity of fire was mixed with a great quantity of water, then either the moisture and cold of the water might surmount the heat and dryness of the fire, so as that the whole should become water, or the moisture of the water might surmount the dryness of the fire, while in its turn the heat of the fire surmounted the coldness of the water, so as the whole aggregate, its qualities being heat and moisture, should become air, which was regarded as the more natural and easy metamorphosis of the two. In the same manner they explained how like changes were produced by the different mixtures of fire and earth and water, water and air and earth; and thus they connected together the successive transmutations of the elements into one another. Every mixture of the one, not being able to destroy, served only to attemper those of the other. Thus fire, when mixed with water, produced sometimes a watery vapour, whose qualities were heat and moisture, which partook at once of the levity of the fire and of the gravity of the water, and which was elevated by the first into the air, but retained by the last from ascending into the region of fire. The relative cold, which they supposed prevailed in the middle region of the air, upon account of its equal distance, both from the region of fire and from the rays that are reflected by the surface of the earth, condensed this vapour into water. The fire escaped it, and flew upwards, and the water fell down in rain, or, according to the different degrees of cold that prevailed in the different seasons, was sometimes congealed into snow, and sometimes into hail. In the same manner, fire, when mixed with earth, produced sometimes a fiery exhalation, whose qualities were heat and dryness, which being elevated by the levity of the first into the air, condensed by the cold, so as to take fire, and being at the same time surrounded by watery vapours, burst forth into thunder and lightning, and other fiery meteors. Thus they connected together the different appearances in the air by the qualities of their four elements, and from them, too, in the same manner, they endeavoured to deduce all the other qualities in the other homogeneous bodies that are near the surface of the earth. Thus, to give an example, with regard to the hardness and softness of bodies, heat and moisture, they observed, were the great softeners of matter. Whatever was hard, therefore, owed that quality either to the absence of heat or to the absence of moisture. Ice, crystal, lead, gold, and almost all metals owed their hardness to the absence of heat, and were therefore dissolvable by fire. Rock salts, nitre, alum, and hot clay owed that quality to the absence of moisture, and were therefore dissolvable in water. And, in the same manner, they endeavored to connect together most of the other tangible qualities of matter. Their principles of union, indeed, were often such as had no real existence, and were always vague and undetermined in the highest degree. There was such, however, as might be expected in the beginnings of science, and such as, with all their imperfections, could enable mankind both to think and to talk, with more coherence concerning those general subjects than without them they would have been capable of doing. Neither was their system entirely devoid either of beauty or magnificence. Each of the four elements having a particular region allotted to it, had a place of rest, to which it naturally tended, by its motion, either up or down, in a straight line, and where, when it had arrived, it naturally ceased to move. Earth descended till it arrived at the place of earth, water till it arrived at that of water, and air till it arrived at that of air, and there each of them tended to a state of eternal repose and inaction. The spheres consisted of a fifth element. Aristotle's view of the ether was never as widely accepted as the following account implies, being criticized not only by the Epicureans but by many of his own successors. It should not be assumed that all who accepted the concentric spheres as an astronomical hypothesis subscribed to it. See P. Moreau, article Quinta Essentia in Pauli's which was neither light nor heavy, and whose natural motion made it tend neither to the centre nor from the centre, but revolve round it in a circle. As by this motion they could never change their situation with regard to the centre, they had no place of repose, no place to which they naturally tended more than to any other, but revolved round and round for ever. This fifth element was subject neither to generation nor corruption, nor alteration of any kind. For whatever changes may happen in the heavens, the senses can scarce perceive them, and their appearance is the same in one age as in another. The beauty, too, of their supposed crystalline spheres seemed still more entitled than to this distinction of unchangeable immortality. It was the motion of those spheres which occasioned the mixtures of the elements, and from thence the production of all the forms and species that diversify the world. It was the approach of the sun and of the other planets to the different parts of the earth, which, by forcing down the element of fire, occasioned the generation of those forms. It was the recess of those bodies which, by allowing each element to escape to its proper sphere, brought about, in an equal time, their corruption. It was the periods of those great lights of heaven which measured out to all sublunary things the term of their duration, of their growth, and of their decay, either in one or in a number of seasons, according. Hello, de Paris également. Euh, According as the elements of which they were composed were either imperfectly or accurately blended and mixed with one another. Immortality they could bestow upon no individual form, because the principles out of which it was formed, all tending to disengage themselves, and to return to their proper spheres, necessarily at last brought about its dissolution. But, though all individuals were thus perishable and constantly decaying, every species was immortal, because of the subject matter out of which they were made, and the revolution of the heavens, the cause of their successive generations, were always the same. Merci. In the first ages of the world, the seeming incoherence of the appearances of nature so confounded mankind that they despaired of discovering in her operations any regular system. Their ignorance and confusion of thought necessarily gave birth to that pusillanimous superstition which ascribes almost every unexpected event to the arbitrary will of some designing, though invisible beings, who produced it for some private and particular purpose. The idea of an universal mind, of a God of all, who originally formed the whole, and who governs the whole by general laws, directed to the conservation and prosperity of the whole, without regard to that of any private individual, was a notion to which they were usually strangers. Their particular occasions were so far from being regarded as the creators of the world that their origin was apprehended to be posterior to that of the world. The earth, according to Hesiod, was the first production of the chaos. The heavens arose out of the earth, and from both together all the gods who afterwards inhabited them. Nor was this notion confined to the vulgar, and to those poets who seem to have recorded the vulgar theology. Of all the philosophers of the Ionian school, Anaxagoras, it is well known, was the first who supposed that mind and understanding were requisite to account for the first origin of the world, and who, therefore, compared with the other philosophers of his time, talked, as Aristotle observes, like a sober man among drunkards, but whose opinion was, at that time, so remarkable that he seems to have got a surname from it. Diogène Laertius reports that Anaxagoras was nicknamed Nous, and confirms this by some lines from the satirical poet Timon of Phlius. The same notion of the spontaneous origin of the world was embraced, too, as the same author tells us, Aristotle, by the early Pythagoreans, a sect which, in the ancient world, was never regarded as irreligious. Mind and understanding, and consequently deity, being the most perfect, were necessarily, according to them, the last productions of nature. For in all other things, what was most perfect, they observed, always came last. As in plants and animals, it is not the seed that is most perfect, but the complete animal, with all its members, in the one, and the complete plant, with all its branches, leaves, flowers, and fruits, in the other. This notion, which could take place only while nature was still considered as, in some measure, disorderly and inconstant in her operations, was necessarily renounced by those philosophers when, upon a more attentive survey, they discovered, or imagined they had discovered, more distinctly, the chain which bound all her different parts to one another. As soon as the universe was regarded as a complete machine, as a coherent system, governed by general laws, and directed to general ends, viz. Its own preservation and prosperity, and that of all the species that are in it, the resemblance which it evidently bore to those machines which are produced by human art necessarily impressed those sages with the belief that in the original formation of the world there must have been employed an art resembling the human art, but as much superior to it as the world is superior to the machines which that art produces. The unity of the system, which, according to this ancient philosophy, is most perfect, suggested the idea of the unity of that principle by whose art it was formed, and thus, as ignorance begot superstition, science gave birth to the first theism that arose among those nations who were not enlightened by divine revelation. According to Timaeus, who was followed by Plato, that intelligent being who formed the world endowed it with a principle of life and understanding, which extends from its centre to its remotest circumference, which is conscious of all its changes, and which governs and directs all its motions to the great end of its formation. This soul of the world was itself a god, the greatest of all the inferior and created deities, of an essence that was indissoluble by any power but by that of him who made it, and which was united to the body of the world so as to be inseparable by every force but his who joined them, from the exertion of which his goodness secured them. The beauty of the celestial spheres attracting the admiration of mankind, the constancy and regularity of their motions seeming to manifest peculiar wisdom and understanding, they were each of them supposed to be animated by an intelligence of a nature that was, in the same manner, indissoluble and immortal, and inseparably united to that sphere which it inhabited. All the mortal and changeable beings which people the surface of the earth were formed by those inferior deities, for the revolutions of the heavenly bodies seemed plainly to influence the generation and growth of both plants and animals, whose frail and fading forms bore the too evident marks of the weakness of those inferior causes, which joined their different parts to one another. According to Plato and Timaeus, neither the universe, nor even those inferior deities who govern the universe, were eternal, but were formed in time, by the great author of all things, out of that matter which had existed from all eternity. These at least their words seem to import, and thus they are understood by Cicero. but the work is a dialogue, and Cicero himself is not speaking. And by all the other writers of earlier antiquity, perhaps though some of the later Platonists have interpreted them differently. The Neoplatonists followed the interpretation of Xenocrates that Plato used temporal language in describing the formation of the world only as a device of exposition. According to Aristotle, who seems to have followed the doctrine of Ocellus, the world was eternal, the eternal effect of an eternal cause. He found it difficult, it would seem, to conceive what could hinder the first cause from exerting his divine energy from all eternity. At whatever time he began to exert it, he must have been at rest during all the infinite ages of that eternity which had passed before it. To what obstruction, from within or from without, could this be owing? Or how could this obstruction, if it ever had subsisted, have ever been removed? This hardly represents Aristotle's reasoning. In the text presumably referred to, Aristotle does not ask what could hinder the first cause from exerting his divine energy from all eternity. His argument is that the eternal motion, which is an evident fact, positively requires a first cause, of which activity or actuality is the essence. His idea of the nature and manner of existence of this first cause, as it is expressed in the last book of his Physics and the 5 last chapters of his Metaphysics. Smith seems to forget that this is not the last book of the Metaphysics, or he may intend to dispute the traditional order of books. Is indeed obscure and unintelligible in the highest degree, and has perplexed his commentators more than any other parts of his writings. Thus far, however, he seems to express himself plainly enough. That the first heaven, the text of the original edition has heavens, presumably a printer's error since the verb revolved is singular. That of the fixed stars, from which are derived the motions of all the rest, is revolved by an eternal, immovable, unchangeable, unextended being, whose essence consists in intelligence, as that of a body consists in solidity and extension, and which is therefore necessarily and always intelligent, as a body is necessarily and always extended. That this being was the first and supreme mover of the universe, that the inferior planetary spheres derived each of them its peculiar revolution from an inferior being of the same kind, eternal, immovable, unextended, and necessarily intelligent, that the sole object of the intelligence of those beings was their own essence, and the revolution of their own spheres, all other inferior things being unworthy of their consideration, and that therefore whatever was below the moon was abandoned by the gods to the direction of nature and chance and necessity. This is verbally correct, but one must consider what nature means for Aristotle. He holds that all things have by nature some part in the divine, and develops his thought in De Partibus Animalium, see translation of the chapter by D.B. N. Balm, Aristotle's De Partibus Animalium, Clarendon, Aristotle. Further, nature aims without conscious provision at ends or purposes, and in this respect the human arts are said to imitate her while falling short of the accuracy of her operations. For though those celestial beings were, by the revolutions of their several spheres, the original causes of the generation and corruption of all sublunary forms, there were causes who neither knew nor intended the effects which they produced. This renowned philosopher seems, in his technological notions, to have been directed by prejudices which, though extremely natural, are not very philosophical. The revolutions of the heavens, by their grandeur and constancy, excited his admiration, and seemed, upon that account, to be effects not unworthy a divine intelligence; whereas the meanness of many things, the disorder and confusion of all things below, disorder and confusion is a travesty of Aristotle's views on all things below, exciting no such agreeable emotion, seemed to have no marks of being directed by that supreme understanding. Yet, though this opinion saps the foundations of human worship, and must have the same effects upon society as the theism itself, One may easily trace, in the metaphysics upon which it is grounded, the origin of many of the notions, or rather of many of the expressions, in the scholastic theology, to which no notions can be annexed. The Stoics, the most religious of all the ancient sects of philosophers, Smith writes again in TMS of the religious character of the Stoic doctrine of cosmic harmony. His long account of Stoic ethics in TMS also contains frequent references to religion. Seem in this, as in most other things, to have altered and refined upon the doctrine of Plato. A similar judgment recurs in ancient logics. It is perhaps derived from Cicero's statements that Zeno was not justified in founding a new school since he had little to contribute but a novel vocabulary. The originality of Stoic formal logic was not appreciated until the 20th century. Expositions which emphasize the originality of many Stoic doctrines have been given by Monsieur M. Joseba Pollens and S. Sambursky, The Physics of the Stoics. The order, harmony, and coherence which this philosophy bestowed upon the universal system struck them with awe and veneration. As, in the rude ages of the world, whatever particular part of nature excited the admiration of mankind was apprehended to be animated by some particular divinity, so the whole of nature having, by their reasonings, become equally the object of admiration, was equally apprehended to be animated by a universal deity, to be itself a divinity, an animal. A term which to our ears seems by no means synonymous with the foregoing, whose body was the solid and sensible parts of nature, and whose soul was that ethereal fire which penetrated and actuated the whole. For of all the four elements, out of which all things were composed, fire or ether seemed to be that which bore the greatest resemblance to the vital principles which informs both plants and animals, and therefore most likely to be the vital principle which animated the universe. This infinite and unbounded ether, which extended itself from the centre beyond the remotest circumference of nature, and was endowed with the most consummate reason and intelligence, or rather was itself the very essence of reason and intelligence, had originally formed the world, and had communicated a portion, or ray, of its own essence to whatever was endowed with life and sensation, which, upon the dissolution of those forms, either immediately or some time after, was again absorbed into that ocean of deity from whence it had originally been detached. In this system, the sun, the moon, the planets, and the fixed stars were each of them also inferior divinities, animated by a detached portion of that ethereal essence which was the soul of the world. In the system of Plato, the intelligence which animated the world was different from that which originally formed it. Neither were these which animated the celestial spheres, nor those which informed inferior terrestrial animals, regarded as portions of this plastic soul of the world. Upon the dissolution of animals, therefore, their souls were not absorbed in the soul of the world, but had a separate and eternal existence, which gave birth to the notion of the transmigration of souls. Neither did it seem unnatural that, as the same matter which had composed one animal body might be employed to compose another, that the same intelligence which had animated one such being should again animate another. But in the system of the Stoics, the intelligence which originally formed, and that which animated the world, were one and the same; all inferior intelligences were detached portions of the great one, and therefore, in a longer or in a shorter time, were all of them, even the gods themselves, who animated the celestial bodies, to be at least resolved into the infinite essence of the almighty Jupiter, who, at a destined period, should, by an universal conflagration, wrap up all things in that ethereal and fiery nature out of which they had originally been deduced, again to bring forth a new heaven and a new earth, new animals, new men, new deities, all of which would again, at a fated time, be a like conflagration, be swallowed up in a like conflagration, again to be reproduced, and again to be redestroyed, and so on without end. J'arrive dans un autre live pour la partie suivante.